Now let us come back to this project. I have given you, so this was the earlier we were dealing with the first 3 columns, we had activity, we had duration, we had predecessor. Now we are also dealing with, we are calling this a normal duration, right. Now I am giving you crash duration and I am giving you normal cost and crash cost. These are the inputs we need to be able to do a calculation to find what is the how much should I what is the cost of crashing. So we had the 14-day project duration, and what we are going to do is to determine minimum cost of completing the project as the duration starts reducing. Okay, so for example, so here we can, how much would it cost in 13 days, 12 days, okay, and what is the maximum I can crash the project to. So as an initial exercise we will go through, we will take the simple problem and work it out for each of the days of reduction in duration. So what do you think when you look at this intuitively, what is the first step you would do?
Crash those which cost lesser.
Crash course which crash those which cost less. Pardon? On the critical path, right. So you can see the the ABCD is on critical path. So I have to find the cost of crashing A, unit cost of crashing A, unit cost of crashing C, unit cost of crashing D, and then use that as my benchmark. Okay, so if I go into the next level, I have actually calculated the days. So here you can find, you will see that we have all these, we have all the values we had earlier. I have used these values to calculate crash days. Crash day is the normal day minus crash day, that is how many days can I crash by. So for example, we are making an assumption A cannot be done in less than 2 days, I am sorry, less than 3 days, right. The maximum I can crash A is 2 days, or C cannot be done in less than 3 days. So these are assumptions that go along with the network. Okay, so let us take this, let us get to the board and see how we would work this. So we have the network A, B, D, we have the 5, okay, so that is on one side. So now if I look at the crash cost, so what are my options of crashing? I have an option of crashing A at what cost?
20, 35.
At 25, okay, per day, and I want to take it stepwise. I want to go all the way from 14 in steps of 1, okay, to the last, because that will illustrate what we are trying to do. I have an option, so in my first step I have A at 25, B, should I use B at all? No, okay, so I do not even want to use B because B is not on critical path. C, C is 175 per day, then the value is there, right, and D 50 per day. What would I choose? Okay, I will choose to crash A, and for now I am going to choose to, so basically what I am going to take A and move it down to 4 days. So my duration here will go to 4. Okay, and this first step has basically cost me 25 rupees or units of cost. Okay, I put units of cost as U there because I did not want to use a currency value as of now. Okay, we are just looking at the value. Now what has, so we have managed, so for doing this in 13 days, so at 14 days it was my basic cost, 13 days I had to spend plus 25. Okay, now as my second step, again what is my critical path? ACD, options are, yeah, it's the same options. Okay, again there because A can go up to 3, and in my second step also I use A by 1. Okay, so again it cost plus 25, cumulative is 50, for moving from this step to this step it's 25. Okay, now I want to go to my third step. What are my options? What has happened to A now? A is fully crashed, so I cannot touch A. Okay, 3 days is the duration in which we have to do, I cannot crash A anymore. Now my critical path is going through ACD, and my options are either C at 175 or D at 50. Obviously it's 50 D by 1, okay, at 50. Okay, how, so D has now moved from 3 to, I'm going to use a different color here, and this has gone down to 11. What has happened to D now? It's, I can't, so D has also reached the maximum crash, I can't move this anymore, and we are now going to the fourth step, where what are my options? A is fully crashed, D is fully crashed, my critical path still goes through C, and how many days can I crash C by? 3 days. Can I crash C by all 3 days? What will happen?
ABD
Yeah, so if I move this to 3 plus 3, this will go to 6, but then you can see B has already become critical before C went to 6. When C was at how much? C was at 4. When C went to 4 itself, when C's duration was reduced to 4 itself, you had 2 critical paths. So even if I spend all the money and reduce C to 3, I am actually wasting a day, because now B is controlling the path. Okay, so I can do stepwise reduction of C. Okay, so let me get this value here. So when I went down to 11, I added another 50. Okay, so now I can take C and take it down to 5. Let me go step by step. Okay, so that is my only option. My fourth step is I can go C by 2, yes, I can say C by 2. Okay, I just want to take it step by step here. Okay, C by 1 at 175 per day. So I am taking it down to 5 and 8, and this was now 2, right, going to 10. Okay, so to go get it at 10, it's another fine. Now I can go again, my fifth step will also be C by 1 day. I am going to write my fifth step here, right. So now I am going to move this down to 4, 7, 7, 9. Okay. So now what happened? So now let me get this. So this is at, so 9th day, I'm down to 9 days and I have spent another 175. Now both paths have become critical. Okay, so both are 3, 7 and 7. So B has also become critical, and by crashing my A is fully crashed out, D is fully crashed out. The only way I can reduce duration is by reducing B and C. Okay, so for my 6th step I have to do B and C by 1. Okay, so B can go maximum by 1, B can only move to 3, take it to 6, and after that B is maxed out. Okay, C also goes from 4 to 3, goes to 6. Okay, both of them come on 6 here, plus 2, 8. Okay, and the cost is how much? B plus C.
75.
So that is 75, B is 75 plus C is 175. Okay, so my 8th step I get at plus 250. So this is my variation of my direct cost. Okay, so my additional direct cost. Now let me put a table here which says, let me put a column which says direct cost. So you can see that my, if I did this within 14 days, what is my total cost? Base cost is how much? You can add up. So okay, that is the normal cost. Okay, 250, 300, 350, 300, 1200. And as I go down, my cost keeps increasing. Okay, so I can now do this computation. Let's do it. So remember, so to do in 13 days, how much is it going to be? I'm going to do cumulative. Okay, 1 2 2 5 1 2 5 0 1 1 5, no, this is plus another 175. Okay, 1 6 1 9 okay, so this is my total direct cost on the, on what, so on the project, so this is my whole project cost, and if I plot a graph, you will see that as the project duration decreases, my direct cost is increasing. Okay, so I have a graph on the PowerPoint. Let me just go through the PowerPoint so that we go through this in this way. So we did all of this as we went through. We first crashed A, okay, as a step 1, and we, so when what was 14 became 13. Okay, then in the second step we crashed A again, brought it to 12. Okay, and then next step we took 12 and we choose to crash D 11, and then we said A and D cannot be crashed any further. Okay, we found critical path was still ACD. We had to crash C. We crashed C by 1. Okay, and then we went back again, crashed C again by 1, and now both paths became critical. and then we had to do C and B by 1 and we reached the maximum crash duration, okay, which was 8. So this was the maximum crash, and we now have a plot of the, what we have done here, we have a plot of the for the project duration versus project direct cost, okay, and you can see that this is the nature of the graph, okay, and what I have shown here is the slope of the graph as it for each step in which we crashed. So we went, this was the first steps of A, D, C and B and C. So this is typical, and obviously because we are looking, so this graph shows the minimum direct cost of the project as we reduce duration. Now this is the outer envelope, this is the minimum graph. I can reduce, as you can see here, I do not need to reduce A first, I can reduce in my first step. If I had reduced C first, what would have happened? I would have still got a reduced project duration, but at the expense of additional money. So I mean I can have different graphs of relationships between project direct cost and project duration, but this is the envelope of minimum, okay. So for example, I mean you can have a similar envelope for maximum. What would be the maximum cost to, which means when I come down to my first crash, what should I crash? C. I could do the total reverse and I will get the envelope for the maximum, right. Right now if I crash B and C together, will there be any use? No, yeah, right. So in each thing I would go with the maximum and I would get the envelope of maximum. So just remember that this is only one of the curves you can plot for cost time, direct cost versus time, but this is the minimum and this is what we are interested in, okay. Any questions on this so far?
What is the maximum crash cost?
There might not be a need in a specific project, but you might want to know the extremity of what, let us say you do not go through the procedure very systematically, what is the border, what is the envelope of where your cost can go to, okay. Having said that, I should also say that if you go into practice, very few times is this procedure used. While it is a, what do you say, a nice procedure from a network analysis point of view and from a mathematical relationship point of view, it is not very much used in practice because of issues in quantifying all of these costs. And then if we are using a linear assumption, it might not even hold good in a practical situation, and so all the analysis does not really yield you a result, and then people do not go into the trouble. So fast tracking is used very much to reduce duration, and if they are going to do this, it is probably still done more heuristically. Until we can get much better models of cost time relationship for activities, we will be limited from using this in practice, okay. Now let us move on. We now add something called indirect cost to this, okay. So far we have talked only about direct cost, but there are many other costs on a project, okay. So for example, the salaries of the project manager, the project engineers, establishment of facilities on the project, okay, things like tower crane, batching plant, you do not bill this to a activity, it is general costs on a project which is there. You are going to pay for electricity on the project, you are going to pay for facilities, all of these are generally called indirect cost, okay, and they are indirect as in they are not direct to an activity, they are general project overhead or other expenses. Now what do you think is the relationship between project duration and, or let me ask you this way, what do you think is indirect cost and how does it vary with time on a project? Each day, yeah, it would be constant. Each day I would expect to pay about the same indirect cost, because assuming my staffing levels are the same, my electricity usage is about the same, you know, I have to pay for site establishment charges and all of this.
Obviously,
that is it. When the duration is, so what I am saying is on a daily basis I will pay the same amount, rate per day is about the same. The total will obviously change, the total will obviously change, okay, but my rate in per day is the same. And if I actually go into the, if I take the rate per day the same, and as I start increasing my project duration, what happens? Cost goes up, and if I start decreasing my project duration, obviously the cost goes down. So while our direct cost is, how is the direct cost changing? The direct cost is changing, is increasing with decreasing project duration. The indirect cost is decreasing with project duration. So now is there should be some area in between where the total project cost, which is direct cost plus indirect cost, will reach an optimum or a minimum value in between this. Okay, so let us see if we can calculate, or let us see how this behavior takes place. Okay, so what I have here is a table, and you can see the values we have put out here are the total project direct cost. Okay, that is the values we have here, 1200, okay, 1475, 1650. Okay, what I have now added is I am assuming a indirect cost of 100 per day. So every day there is a charge of 100 for which the project is active, which means if I am there for 14, it is 1400. Okay, as my project, so if I am going to put these values here so that we can also kind of see. So as my project duration decreases, okay, it is straightforward. I made the numbers straightforward so we can think through it. So here you find increasing, and here you find this is indirect cost, here the numbers are decreasing. Now if I sum it up, okay, I get okay 25, yeah, can you read it out to me so that I can write it down? 2450, 2400,
2475,
2475,
2550,
27. What is the pattern you see? Okay, so this is basically a sum of direct and indirect. What is what we are doing? What is the pattern you see? Yeah, 26, 25, 24, 50, 2400, and then it starts increasing again. Okay, so this 11 days, if I can finish, if I can bring my project to the 11th day, I have a, actually this is higher, this I have the optimum value. Now the graph can be shown this way, okay, where I have my direct cost, we saw this graph, my indirect cost going up, okay, and decreasing as the project duration decreases. This is the total cost, and you have the total cost decreasing and then increasing. Okay, now can you, we talked about cost per day, reduction in cost per day and all of that. I mean the crashing from activity, we talked about crashing cost per day. Or in overhead cost we talked about a constant value on each day. So can you rough guess where this optimum or where this minimum occurs? I am going to actually go back to this graph. What is the relationship between
activity C has been considered.
Yeah, no, what is the relationship between my overhead cost value and my cost slope value?
Slope changes drastically.
Is there more than drastically? Can you quantify? See here, right now here the cost of 1 day of crash is 25. How much do I save? On my indirect, how much do I save? 100. So my total saving is 75. Here again my total saving is 75. 50. Once I cross this, my how much I pay for my indirect, the slope, the amount is more than what I save on my, I'm sorry, what I spend on my direct is more than what I save on my indirect. Okay, and so that's why the graph then starts increasing. Okay. Now this is an interesting relationship, and I mean, so this is true in practice. Challenge is really to get the good value, good data to find where this project duration lies, where I will experience minimum cost. Okay. Now let us just summarize. When we look at the steps for crashing, we have to identify the activities on critical path. We have to compare the unit cost, okay, of the activities on critical path, and there are combinations to select what we need for crashing. Okay, and then we finally actually select the activity combination with minimum cost. And in case of a tie, if there is a tie between few activities, it is always better to select the activity which has more influence on the network. We will see this when we come to some examples which we do later. Okay, so then we reduce the duration of activity combinations and ensure no other path becomes critical if duration is reduced by more than 1 day. We saw that in B. When C, we can't reduce C by too much, because by more than 2, because B will become critical. And then once you do the reduction, recalculate the network, go to step 1, go back through the process, repeat the step until there is no further crashing can be done. So in 2 you will have to find out, is there any further crashing possible, and if not, stop.